Electrical Engineering, a lesson where you find circuits everywhere. Have a headache, but suicide is not the solution. Budi has made a schematic of a filter and he's ready to build one. However, he just realized that he only has a piece of 10k ohm resistor. Oh no! Fear not, because the problem can be solved using magnitude scaling. Magnitude scaling is a process of changing components' values without affecting the frequency response of a circuit. By multiplying the independence of RLC by a scale factor of magnitude Km, the equation on the screen are obtained. Since omega 0 accent equals to omega 0 and key accent equals to key, the resonant frequency remains the same. Now, let's help Budi.
As Budi has stated earlier, Budi only has a 10 kilo ohm resistor, while he needs 1 ohm resistor in his schematic. He doesn't need to make a new schematic, he only needs to do a magnitude scaling. The Km value is the ratio between the used value of the impedance versus the planned value of the impedance. After we got the value of Km, we can directly calculate the value of the inductance and capacitance that are needed for this circuit. In conclusion, if Budi want to use his 10 kilo ohm resistor, he need new values of inductor and capacitors that are shown in the slide. By doing that, Budi can once again pursue his circuit. What if Meimei wants to maintain the impedance but changing the cutoff frequency? And that is contradicting with what Budi wanted, so Meimei cannot use magnitude scaling. So what can Meimei do? Things that Meimei can do is by doing frequency scaling.
Frequency scaling is used to shift the frequency response of a circuit up or down without changing the magnitude. In frequency scaling, resistor is frequency independent, thus it is unaffected. The first equation you see on the screen must be satisfied by the new inductor Lxn, which has the same impedance at the scaled frequency omega 1 xn. Using this method, the new inductor value Lxn is obtained. And of course, by using the same method as the inductor, the new value of capacitor Cxn is obtained. We need to remember that omega 0 xn equals to scale factor of frequency times omega 0 and bandwidth xn equals to scale factor of frequency times bandwidth. In frequency scaling, the resonant frequency and the bandwidth are affected. Now, let's help Meimei.
Previously, Meimei stated that she wanted the frequency response to be shifted from 1 rad per second cutoff frequency to 50 kHz. By that, we can calculate the Kf. Kf is the ratio between the actual frequency versus the planned frequency. By doing the calculation, we will get the Kf. After we got the value of Kf, we can directly identify the new values of the inductance and capacitance by using the equation that has been explained previously. By using these new values, we can be assured that the impedance of the circuit will remain constant, while the frequency of the cutoff will change.
Can we combine the frequency and magnitude scaling? And the answer is, of course we can. If we combine both of them, magnitude scaling and frequency scaling, then it will be called magnitude frequency scaling. What are the differences between these three? Okay, the first column is the magnitude scaling. You can see the equations of magnitude scaling there. In frequency scaling, as I said before, the resistor is unaffected because it is frequency independent. With that being said, you can see the equations of frequency scaling in the second column. And if we scaled magnitude and frequency at the same time, you can simply use the equations in the third column.
The example of the frequency and magnitude scaling is shown in the video. What if we want to change the cutoff frequency from 1 rad per second to 50 kilohertz like May made it? And by changing the resistor from 1 ohm to 10 kilo ohm like Budi did? Because we are doing a magnitude and frequency scaling, there are two constants that we need to find. The first one is Kf and the second one is Km. The Kf value and the Km value have already been solved in the video. After we got the values of Kf and Km, we can directly insert it to the equation that have been explained previously. Actually, when doing a magnitude scaling, we can write the Kf is equal to 1, while when we are only doing a frequency scaling, we can write the Km is equal to 1. So basically, there is only one equation for these three scalings. And that is all that we can explain to you about scaling. Remember, scaling are divided into three: magnitude scaling, frequency scaling, and the combination of magnitude and frequency scaling. That's all from us. Thank you.